grand total of 18 grams per mole. Okay, this is a percentage problem. We want to know percent composition. That's the whole name of this section, percent composition. I want to know what percent hydrogen. I want to emphasize by mass. And then we want to know percent oxygen by mass. We never go percent by number of atoms. We never say, okay, there's 3 atoms that have gone to make this molecule up. 2/3 are hydrogen and 1/3 oxygen. No, we never do that. It's always percent composition by mass. So if you think mathematically, you could probably crack this code. Okay, 2 out of 18 is coming from the hydrogen. And so percent hydrogen will go 2.0 contribution over 18, but I want percent, what else do I have to do? Times 100. Okay, and now, how would we set that up for oxygen? Right here, Liz, what would you do if I want percent by mass oxygen?
16 over 18.
Perfect. 16 over 18 times 100. Let's do it. There's a question of 6. Let's go. Let's go for 3. I'm being arbitrary here because if you look at that, you'd really say 2 for this one and 3 for this one. Let's go for 3 both places. I want to know what percent is hydrogen. So let's punch that through. Aaron, what'd you get? Percent hydrogen is 11.1%. Okay, now let's do it this way and come up with percent for oxygen. Right here. Marco, what'd you get for oxygen?
88.8.
88.8. Okay, is that what everybody got? 88.8? Okay. How can we check a work?
Adding 100.
Add them together. Because it better be 100%. Now, you may find it's not quite 100. It can be a tiny bit more. Like if it's 100.1 or if it's 99.9, no sweat. Because see, you've rounded here possibly and you've rounded here. But you can add those 2 together. Okay, now you might be thinking a nice shortcut. It's a 2-component system. Once you know that one, subtract it from 100. But hey, if you screwed up on the first one, you've now screwed up on the second one. So if you were working a test question, I would say, do it this way, because then when you add these together, if it's not really close to 100, you know you've screwed up, go back and check your math. So percent here by mass. Remember back in chapter 1, we did that penny percent thing? So we're going to be doing percentages all along this semester. So percent composition. Now I want to ease us in. We'll come back and work another one of these on Thursday. But I want to ease us into these 2 sections just to get an introduction so you'll have time to think about it a little bit. Empirical formula is sometimes referred to as the simplest formula or lowest whole number ratio. That's one thing, and that is section 8. Section 1. Now, empirical, if that's a problematic word for you, it just means it's coming from an experiment. Empirical evidence, that you've actually seen it with your own eyes in the lab, or you've observed this. So it's coming from an experiment. Now, where the molecular formula is the so-called true formula. Let me give you an example. If I took some hydrogen peroxide to the lab, pure stuff, and I analyzed it, I would find it's one H and one O. Okay, it's 1 to 1. But then I would do another experiment, and I would find that the formula weight of hydrogen peroxide is equal to 34 grams per mole. Okay, here's your first experiment. This is a second experiment independent of the first. In the first one, I discovered in the formula it's a 1-to-1 ratio. Then I discover in a second experiment the actual formula weight of hydrogen peroxide is 34. Okay, so the question is this also the molecular or true formula? If I added this up for formula weight, can anybody do that for me? Just as an H and an O, it'd be what? 17. Is that 34? Of course not. So 34 is equal to 17 times what will get me there. And what's the what? 2. So what that means is hydrogen peroxide, I double everything. So here we have hydrogen peroxide. That's the true formula. It's a 2 to 2. If you actually have a molecule of this, the structure goes something like that. An H to an O to an O to an H. That is the true formula. But the lowest whole number ratio is 1 to 1. And one step else, I always like to point out compounds that spell words. For instance, there's a compound, aluminum phosphide. It spells a word, ALP. Okay, I always drive around on 610 watching for license plates that spell chemical words or I have a boring life. So one time in class I go, well look here, we have a word. And I go, ho, and 3 guys laughing fell out of their chairs. So I usually don't do that anymore. But anyway, empirical is the lowest whole number ratio, and the correct one may be the same and it may not, just real quick. If I go back to water, I do experiment 1 and I found out water is 2 to 1. Experiment 1. Lowest whole number ratio, 2 to 1. Second, I find that the formula weight of water is 18 in my second independent, different type of experiment. Okay, is this the true molecular formula? Yeah, because if you add this up, it is 18. And so, the true, in this case, the true and the empirical are one and the same. Sometimes they are, and sometimes they're not. Okay, and let's end it right there. And what we're going to do, we're going to take a 10-minute break. We're going to come back. We're going to talk Lab 5 for a little bit. You're going to take your quiz. Then, if you haven't finished 5, then you'll hike down the hall and do your final weighing, unless you're going to run down there in this 10 minutes and do it. And you're going to turn in 5 today. So top priority is 5. Okay, next priority. If you're going to work Friday night, I want to take groups over to the lab next door and get you trained for Friday night. The other priority, finish up as much as you can. Well, 7A should be completely done. If it's not, work on it. But start into 7B. That's chapter 2. And you're going to be able to go grams to moles to molecules and do all that for practice.